question is taken from Further Maths 2016. That's Waec Further Maths 2016, and it is question number 14. Here the question goes thus: 4 vectors r equals alpha I plus beta j, where alpha and beta are positive constants. X equals 2i minus j, n equals 3i plus 2j, and n equals I plus j are such that the magnitude of r is 3 times as x and is parallel to m minus n. Find the values of alpha and beta. B. Calculate the magnitude and direction of r minus x. So let's get this done. Solution. So let's write out the parameter. We're told that r equals alpha I plus beta j. S is equal to 2i minus j. M equals 3i plus 2j, and n equals I plus j. And n equals I plus j. So we look at this one after the other. We look at the statements one after the other. We are told that the magnitude of r is 3 times the magnitude of x. That is to say, r equals 3x. And the magnitude of r is going to be equal to alpha squared plus beta squared, all in square root, equals 3 into the magnitude of s is the square of the coefficient of I and that of j. So we have 2 squared, square root of 2 squared, plus minus 1 squared. Of course, when we square both sides, the square root are going to cancel at each other. So I'm going to square both sides to remove the square root. So on squaring, this square will cancel at the square root. So we have alpha squared plus beta squared equals, when we square this, we're going to have 9 into the square will cancel at the square root. So we have 4 plus 1. So alpha squared plus beta squared equals 9 times 5, which is 45. So I have alpha squared plus beta squared equals 45. Let's call this equation 1, because we are made to find the value of alpha and beta. And remember that we are told that alpha and beta are positive number constants. So let's go to the next statement. The next statement is that r is parallel to m minus n. So first of all, look for m minus n. M minus n equals, m is 3i plus 2j, 3i plus 2j minus n is I minus plus j rather. So on opening the bracket, we're going to have 3i minus I, minus times I is minus I. I'm collecting like terms, plus 2j minus j. So m minus n is going to be equal to 3i minus I is 2i, 2j minus j is j plus j. So this is m minus n. M minus n is equal to what? 2j. Now I'm going to keep equation 1. Let me keep equation 1 and here, so that we can make sure. I want to rub off the board so that because of space. So equation 1 is alpha squared plus beta squared equals 45. So we'll just keep this here so that we can make use of it. Now, m minus n is equal to 2I plus j. So we'll keep this here too. M minus n equals 2I plus j. So we have this. Now, arrow is parallel to m minus n. Now, when two vectors are parallel, they are equal when you multiply the other by a constant. What I mean is, if I have a vector, let's say ax or axi plus bxj, if it's parallel to cy plus dyj, then it means that axi plus bxy is equal to k multiplied by cy1 plus dyj di. So this shows that they are parallel. So you just introduce a constant and multiply it by this. So that's what we are going to do to the vectors r, and so we are told that r is parallel to m minus n. So vector r is alpha I plus beta j equals k into m minus n is 2I plus j. So we have alpha I plus beta j equals, so we open the bracket, you have 2ki plus kj when we open this. So we are going to compare like terms on both sides. So on comparing, so compare the terms that are with I, that are equal to, that has I or have I, and the ones that have j on both sides. So from here, it means that alpha equals 2k, because this of this, and beta equals k. If alpha equals k and beta equals k, it means that we can substitute this into this to get the value of k. So this was our equation 1. So I'm going to substitute k for beta and 2k for alpha in equation 1. So on doing that, I'm going to have this. So I have 2, so I'm substituting to this alpha squared plus beta squared equals 45. So when I'm substituting to that, I have alpha is 2k, so I have 2k squared plus beta is what, k squared equals 45. So when I square, I'm going to have 4k squared plus k squared equals 45. So I have 5k squared equals 45. Simply divide both sides by 5, which is 9. Now we're going to get the positive value of k only, because we are told that alpha and beta are positive values. So k is equal to square root of 9, which is equal to 3. So therefore, alpha equals 2 times 3, which is 6, and beta is equal to what? 3. So that answers the first part, A. So therefore, so this is A. Therefore, alpha is 6 and beta equals 3. B, we are going to calculate the magnitude and direction of r minus x. So I can rub off this. First of all, we look for r minus x. So this is B. R minus x equals, so vector So we have gotten our alpha to be 6 and beta equals 3. So vector r, so have to look for vector r first. So vector r equals, so this is vector r, alpha I plus beta j. So r equals, our alpha is 6, so I have 6i plus beta j. So beta is 3j. So now we can now calculate for r minus r x. R minus x is equal to 6i plus 3j minus x is what? 2i minus j. So this is going to give us 6i minus times this, we have minus 2i plus 3j, minus times minus is plus j. So this is going to give us 6i minus 2i is 4i plus 3j plus j is 4j. So r minus x is equal to this. Now to get the magnitude of r minus x is equal to magnitude of 4i plus 4j. So this is going to give us the square root of 4 squared plus 4 squared, which is equal to square root of 16 plus 16, that is root 32. And this is going to give us, so we can simplify this to 16 times 2, which is the square root of 16 is 4, which is 4 root 2. So that is the magnitude of r minus x. Now we are asked to calculate the direction. So to get the direction, we are going to use theta equals arctan, the value of y over x. So this is y and this is what? X. So this is going to give us theta is arctan, y is 4, x is 4. So theta is equals to arctan. 4 divided by 4 is 1. And by trigonometry, the arctan or arctangent of 1 is 45. So theta is equals to 45 degrees. Therefore, the direction of r minus x is 0.45 degrees. Alright, thank you for watching. Don't forget to like our YouTube channel, Use Science, for more and exciting videos on mathematics, physics, further maths, and chemistry. Thank you once again. See you in our next lesson.